Now, welcome to Work with Nature vlog. I wanted to make a video on just kind of getting rid of the whole confusion about is a hybrid a GMO? A lot of people, when I talk to them about seed saving, that's what they seem to think. And I wanted to also just show you how to kind of make a hybrid, just so that you get the idea. And in a way, I'm going to make a more in-depth video on how to really do it. But right now, I think it's just the distinction is what I'm going to explain. Okay, now in order to do that, I'm going to have to first of all talk about self-pollinators and open pollinators, and then I want you to remember that information because we're going to use it later on in the video as well. So a self-pollinator is just a plant that, this is okra by the way, it's a self-pollinator. It basically has the female and male parts in the same flower. This is an interesting one because it has the stigma protruding at the top and the pollen is way back there. And that means that it's more likely for a bee to come along if it has some pollen from a different variety of okra. It will actually pollinate it before maybe the pollen can get onto the stigma. And there's about a 30% rate of that happening. Now, self-pollinators don't have a problem with inbreeding depression, and that means that if you self it with itself, again and again and again and again, it can deteriorate in the open pollinators, but with self-pollinators this isn't the case. Right, here we have a papaya. That's an open pollinator. It needs either bees or wind to transfer the pollen from a male plant with male flowers onto male parts, so the anthers and pollen, to a female plant with female stigma and female parts, in order for us to get seeds from the fruit of the female plant. That makes sense. Right, so just remember that. Now, open pollinators, of course, do have this whole problem with inbreeding depression, so you need a large population in order to have enough genetic diversity for that to be okay. Otherwise, if you keep breeding the same plant with itself again and again and again, the plant is going to lose genes, and it's going to get really bad after maybe 10 generations or so. Right, now to cover the whole thing, a hybrid, what's a hybrid versus GMOs? I'm just going to cover what a hybrid is first. So a hybrid is a plant where you can you take two distinct parent lines and you cross them together. So this is a very distinct, all self-pollinators are pretty much distinct parent lines because they've bottlenecked so much, and they're not affected by the whole bottlenecking, that they have become very distinct traits. So they're always showing the same traits generation after generation with the same amount of vigor. Now, if I cross this one with a different variety of okra, I'm going to get a hybrid F1. So that's an easy one to make a hybrid from because it's a pretty much self-pollinator without problems with inbreeding depression. Right, so now the story goes a lot different if I'm going to take, say, sweet corn, which is an open pollinator. I first have to create we have to kind of make each sweet corn variety that we want to consider crossing to make a hybrid, we have to reduce it down. We have to keep self-pollinating it basically to itself, so those two to itself for like 5-6 generations. And then when we actually cross those two, because they're going to have those distinct traits, when we actually cross those two together, there's a rule in seed saving that the actual seed breeding, that the actual traits that will show are always going to be the dominant ones. So let's say the sweet corn has this one has a white seed, this one has a yellow seed, and the minute we cross them together, either way, it doesn't matter, you're going to get yellow seeds showing. Now, sweet corn has a lot of different kind of traits that are dominant and a lot of traits that are recessive, and that just means the recessive ones won't show in the first generation. Now, the story is of course different. The minute you sow that seed again, it's going to split up into loads of different kind of mixes of genes. The whole pool is going to get mixed, and it's going to express into the recessive and the dominant strains. So you might get some yellow, some white, and don't forget, if you take all the different types of recessive and dominant traits, and you're going to have quite a mixture of different things showing and not showing. Right, and that's pretty much how you make a hybrid. What you would then do is you would you would pretty much usually mix it up. You can do this thing of mass selection where you just keep letting it breed with itself again and again and again until and roguing out and taking out the ones that you don't want, the undesirable ones, and eventually, and I'll get more into it in a later video, but for now, just to suffice, you just keep doing that for maybe 10, 8, 12 generations, and eventually you'll have pretty much something that's kind of stable. And with these guys, you'll definitely get something stable after a couple of generations. But with sweet corn, which is and all open pollinators, you'll never really get a kind of a stable variety. It's always going to show a bit of different traits due to the fact that there's so much. Because you need the large number of plants, there's going to be quite a lot of differences, and it's a kind of a trade-off because you can never, you can make it again narrowed down, but then eventually you're going to end up with the whole problem with bottlenecking. So that is what a hybrid is, that's what a stable variety is. You can deduce that from this whole explanation. Now, a GMO, we all probably know that it's where you take the gene of a fish and you stick it into a vegetable. That never will happen naturally under no circumstances, and we do not know what the consequences will be in the future. And that's pretty much simply what it is. I could go into the science of it and explain that, but it's just simply put, it's where you take a gene from a different kingdom and you stick it into a different kingdom, into a plant, to get whatever desired results you wish to get. Now, I hope that explained the whole thing, and I will explain more about the whole kind of breeding thing, because I want to do a sweet corn breeding project now, and I'm thinking even to kind of show you step by step as I go along, because sweet corn in the tropics will go to seed, from seed to seed, within about 3 months, so I can get about 4 generations into a year, which is really amazing. I mean, compared to 1 generation in the West. So we can actually do a kind of a showcase of how to do the whole sweet corn breeding. Now, I hope you enjoyed the video, and as always, thanks for watching. I might see you in the next one.